OBS has just fallen apart in terms of its quality. I have to say, it's very strange for such a commonly used resource to be this low quality in its release. I understand it's open source. I understand it's free, but yeah, it's tough. Okay, so we'll be showing you how to do graphical effects like that later on in the course. Let's get going. GameStop stock is experiencing what's called a short squeeze. It's an interesting financial phenomena where essentially short sellers have been trapped. When you buy a stock, usually you want to go up, right? If it goes up, you can sell it for more money than you paid for it, you make money. If it goes down, you lose money, right? However, short selling reverses this. You buy a share, you borrow a share for a limited amount of time, you immediately sell it, and then later on, you're forced to buy it back. Hopefully, the stock goes down in value so that when you have to buy it back, it is cheaper than the price at which you sold it. You get to keep the difference. If it goes up, however, you're in trouble. And if it goes up too much, you are forced to buy it immediately at that price. And people being forced to buy it causes the price to go up, right? Which forces more people to buy it, which causes it to go up, and then it spikes like this. This is called a short squeeze. It's a really, really interesting concept. At the very least, it's gotten GameStop's crazy activity lately has gotten a lot of people to look into these financial concepts, which is really good for their education. So anyway, it's not really related to game dev. It is perhaps the most interesting thing to happen to GameStop in a long time, which is a games industry company. So, okay, let's keep going. Last lecture, we talked about components and composition, and we talked a little bit about the fact that you want your components to be small. You want them to be very straightforward in the jobs that they do so that you can understand them, you can debug them. When something goes wrong, you know which component to look at and figure out and fix. Well, if you make your components 5,000 lines long, if you give them too many jobs to do, then you're in big trouble. I'm going to show you a component taken from Yandere Simulator. One of my friends discovered how to basically decompile the Unity code from this game. And oh, good gosh, imagine having this many variables, this much state organized this way. You've got hundreds of variables, and you've got, I think, one function that is used. Here's the function. Here we go. Go. Oh my gosh. The only thing that is used for control flow in this entire component is if statements. That's it. No polymorphism is using, no inheritance, no interfaces. We got our update function. Right? Imagine trying to fix a bug in this code base. Imagine trying to add a feature. And you know that there are, with any given feature, to like even add a character to this game, you have to edit like probably 30 different lines of code to add that character in 30 different places. Imagine having a typo or putting it on the wrong line, and then there's a bug that you don't know about. Oof. Anyway, it's tough. Okay, you don't want your components to look like that. This lecture will show you how you want your components to look. Have them be very simple and have them be kind of hardy and flexible, okay? Okay. A very easy to use technique, 2D parallax. Parallax is an extremely, extremely useful feature. You'll probably use it on Project 2 and 3 if you make a 2D game. The idea is sort of like when you're looking out of a car. Things that are close to you move quickly. Things that are far away in the distance, like mountains, do not move quickly. And this gives you the sensation of depth. This is an entirely 2D game, but the fact that the nebula back here moves slower than the stars that are closer to your character means that you get this sensation in your brain that the world is deeper than it actually is. It's full of depth, and just imagine the exploration you can do, right? And it's extremely easy effect to implement. We'll talk about it a little bit later. Okay, Wednesday, we will be beginning on game design. We will be starting on Wednesday because you need to get this knowledge before you do your Project 1 Gold, which is coming up. You've got about a week and a half until it starts. And on Project 1 Gold, you'll be required to implement a new mechanic and then a new level that uses and highlights and emphasizes different aspects of that mechanic. You've got a mechanic and then a level that explores it, okay? It doesn't even need to be a very long custom level. It just needs to explore several different ideas with your mechanic. It could be 4 or 5 dungeon rooms if you were doing Zelda, as long as each room is impactful and interesting and novel and well-guided. Okay. Yeah, this is a funny announcement. So I'm releasing a game tomorrow, my company is, which is why I'm very sleep-deprived right now, but that's okay. I hope it doesn't affect the lecture too much. It is a game called Goodbye Groundhog on itch.io. It is a very simple and very short tower defense game in which you play as a groundhog, in fact, a family of groundhogs, who have been blamed for a non-ending winter. The moon has disappeared, winter has not ended, and of course everyone knows the rumor, right? When groundhogs see their shadow, it causes winter to extend. And so, unfortunately, this rumor has caused the entire forest to turn against you, and you need to go warm their hearts and defend yourself in a really simple tower defense game. Okay? So anyway, hopefully it comes out. It's not too buggy. It's certainly not going to be very long, but that's okay. We only spent about 2 weeks and about $300 on it, so it's okay. Anyway, you can look it up. If you don't want to pay for the bundle, it's going to come in a bundle of 13 Michigan-made games. So if you don't want to pay for that, you can just send me a message and I'll send you a free code. Okay. All right. Fun P1 bugs. I want to say something about P1 milestone. In the assignment spec, I'm pretty sure it discusses this. In the rubric, it definitely does. You don't need to have these tasks for P1 milestone perfect. You don't need to have them perfectly authentic. You don't need to have them bug-free. They can be somewhat incomplete. They can be buggy. They might not always work yet. That's fine. That's what a prototype is. And if you look in the rubric, it says basically if the task exists, if it's in the game and is somewhat recognizable, you're getting those points, even if it's super buggy. There is no column for bugginess on your P1 milestone rubric, okay? On P1 Gold is when everything needs to be bug-free and very authentic, okay? But that's not coming up for about 2 or 3 weeks, okay? Okay, if you're confused about any of this, you can always ask me on Piazza or on Discord. I get the impression that some teams thought everything needed to be perfect and maybe had a harder P1 milestone than they should have. The good news, though, is that if you did perfect some of these tasks, you're going to be at a really good place for P1 Gold. You'll be ahead of the game, okay? Code quality is never checked in this course unless we can't get your game to run. We will know whether you're using the proper design patterns basically based on how much sleep you get. And you will want to use these techniques, okay? That is the key to doing well in this course. Okay, I want to show you some bugs that are very common on P1. This is one where the game is showing the player that the player is looking to the right, but internally the game still thinks the player is looking downward. So when they shoot, the bullet, the sword comes out of the wrong end, okay? A very funny bug, not so funny on P1 Gold though. This one's particularly funny. Sometimes the cap on the number of sword projectiles that can exist, which is 1 at any given time, is not enforced. And so the game turns into Galaga, or like a shoot 'em up game. Sometimes there are room transition bugs where maybe the player will move too much during a room transition and it will place you into a really poor location. For instance, inside of a block where you can't escape. We'll talk about this. Go-tos are authorized. Yeah, you don't want to, you'll regret that if you start using those. Okay, so anyway, all right. So by the way, this situation right here where you get stuck inside of something is called a soft lock. And it's referred to as a soft lock. We'll discuss this tomorrow on Wednesday as part of the game design lecture. But a soft lock is different from a hard lock, which is the freezing application you might be used to, where you're working in Microsoft Word and suddenly the entire application goes unresponsive, and then Windows tells you, like, hey, this app is unresponsive, you want to close it? This is a soft lock, where the game's still running, all the systems are still working fine, but the design of the game has led to a bad ending, a dead end. There's no possible way to progress the game because something has gone wrong. Okay. Here's another example of when sometimes the rigid body on your game object can get a drift to it, where you like slowly move in a direction even though you're not pressing the arrow keys. Here's another one that reminds me of a movie I saw. I think it was a movie called Wanted. I think it was an Angelina Jolie movie, where there are a bunch of assassins that are able to shoot a bullet out of their guns and then have the bullet actually curve through thin air. And so this is an instance of shooting your magic sword projectile one way and then turning and having it curve and go a different way. Okay, here's another example. This one is extremely common. If you look at this here, Link is actually moving his butt backwards when he thrusts his sword. This looks really poor, it feels really poor, and it makes combat really hard because your sword barely extends. During normal gameplay, Link's torso is meant to stay here and the sword goes out instead of jumping back, right? This is a problem with the anchor point on this sprite. This sprite, where the Link has his sword out, the anchor point by default is going to be in the center of the sprite, but in reality, to get the right effect, it needs to be in the center of his torso, okay? It's a 30-second fix if you know what you're doing. Just go in to the sprite editor on that sprite and then just drag the pivot point over. This is an issue with UI. If you don't set your canvas scaler component to scale with screen size, scale with screen width, something like that, you'll get this effect when you build the game. Your UI will look really weird and poorly sized when you make a build. For Metroid, Google Slides is not wanting to let me progress to the next slide here. Okay, Zoomers. Zoomers are a really, really fun enemy to program in Metroid, but they can potentially be very difficult to, and the bugs are very, very fun. Zoomers can often get themselves lost in midair and just spin around trying to find a wall. I'm sure some of you have seen that. Has anyone in chat seen that? There is another bug, I like this one as well, where you're in a morph ball and you're in a tight space, but the game forgets to prevent you from unmorph balling, and you get yourself jammed into the ground. That's not good. Another fun bug, probably my favorite bug that I've seen in Project 1, is a bug where the zoomer looks at the player and says, yeah, that's a wall, and uses it to get to the ground and escape. It's extremely, extremely fun. And this bug in particular looks like it could be a really cool game mechanic to me. You can imagine a custom level where Samus gets a suit, a special suit that allows her to have zoomers climb without taking damage. And your entire objective is to help zoomers get to a certain location in the room to hit a switch to open a door or something. And you have to be at the right place at the right time to help the zoomer climb, okay? To route the zoomer around. That could be really cool. Don't let me design your game for you, though. You should make the custom mechanic and level that you want, so long as it can meet the game design criteria we provide on Wednesday, okay? Okay, you've got an assignment released today. If you look at the calendar, if you look at the schedule, you should be currently working on P1 research. You should be working on, you should be finishing and submitting P1 milestone. If that's not in, you've got less than 24 hours to get that in, so please do so. You've got P1 Alpha launching today, and you should be doing your project management, of course. Let's take a look really quick at P1 Alpha. This is a very, very similar assignment to P1 milestone. It's just your task set has gotten different, right? You have more tasks now, and that might actually scare you. You have more tasks. That's going to be nasty, right? The good news is that the tasks that you need to do are very, very similar to the tasks that you've already done. So in P1 milestone, you've already implemented an enemy. Now you need to do 4 or 5 more. You've already implemented a weapon. Now do 2 or 3 more. And remember, for P1 Alpha, it doesn't need to be perfection either. It can be buggy. It can be incomplete as long as it's in the game. You'll get those points. And then for P1 Gold, you'll have to fix it all up. Okay, let's keep going. Kind of a boring assignment. It's a little bit longer. You don't have 5 days. You have 9 days. So you have a week and a half to get that done. Okay? Okay. What I'd like to do is I would like to show you, I've been saying a lot recently, hey, you want to build your game by building lots of components. You want to build components that are small and simple and easy to understand and debug. You want to build components that are hardy and reusable, that just work no matter where you put them, right? No matter what game object you put the component on, it's just going to work. But I haven't really given you any concrete examples of what that looks like. And so what I want to do is I want to go back to your very first assignment, your rollerball assignment, and I want to show you how you could add a health and damage system to your game using two very, very simple components, and add some enemies to the game as well while we're at it. And we're going to do this really, really fast. So let's go ahead and open up Unity. It's going to be a long night tonight, I'll tell you that. Okay, so let's go ahead and open up our composition example here. We're going to make a few changes to get rid of the previous section's work. I'm going to munch on an egg while we load Unity here. Anyone? Does anyone in the chat have a snack? Anyone have a drink? What are you snacking on? What are you drinking? The slides will show up in the schedule after this lecture, okay? So it's going to show up right here. In fact, I'll probably put them in right now because the first section is probably wanting to join us here. Oh, that looks horrible. 8. Oh my gosh. Very laggy. Okay, let's go down to 8 and let's make sure this wraps real quick. There we go. Cool. All right. Okay. We've got jasmine tea. We've got a pear. We've got water, coffee, Taco Bell. Nice. Kool-Aid. All right. This is one of the few times I've appreciated Unity's slow loads. Hello. Here we are. Okay, good. All right. So here's our rollerball. It isn't quite what the rollerball that you made, but it is largely similar. So let's make sure that we get rid of some of the components that we created. Okay, got rid of that. And we're going to get rid of the box collect. Blah. Okay. We're also going to get rid of this. And we're good. Okay. So this is essentially rollerball. I'll prove it to you. Let's go ahead and roll around here. And we can collect things. We can jump around. This is a little bit unique in that we have this orbital camera where I can use the mouse to kind of look around a little bit. And we got this trail render that looks pretty cool that follows our watermelon. But otherwise, it's essentially what you had at the end of tutorial 1. Okay? I think I need to remove a component from our player here. Yeah. We'll remove has health. And I think we're good. Our player has a movement script. It has a restart if below script, a collection script. So it's all good. Now here's the question. Let's say that we want to upgrade this game. We want to introduce the concept of enemies. Enemies that damage you. And damage means that there must be some sort of health system in our game too. And so the question is, how would we create something like this? How would you do it? Well, if we want enemies in our game, the requirement for an enemy, at least right now, is that the enemy just needs to deal damage to our player and inflict some knockback when you touch the enemy, okay? Maybe we can make them move around later, but for now, we'll keep it simple. You might be very, very tempted to create a new component for the enemy game object. We would go to this game object, the sphere right here, the enemy, and we would create a new component on it and call it isEnemy or something, or enemy component. However, that would not be the best way to do it, okay? Because we might want other things in our game to be able to damage you if you touch them as well. Like this floor. This floor is red, so maybe it could be lava. If you touch it, it should do basically the same thing an enemy would do. So remember back to our composition lecture. When you're creating and designing components and figuring out which ones you need, it really, really helps to think of components as adjectives. So what does an enemy need to do? What does an enemy have that makes it an enemy? How do we take any game object and make it an enemy? Well, an enemy is a game object that when you touch it, it does damage. Okay, that's fairly simple, right? But to do damage, we need to have something have health. So let's go to our player, and we're going to give it health. Okay, and think about adjectives. Let's create a component called has health. And we've done this 3 times so far, so we're going to create has health 3. Okay? The idea is any game object that has this has health 3 component has a health value, okay? And is capable of taking damage and being destroyed if their health goes too low. So we could give this to a player, but we could also give this to an enemy. And we could give this to a wall if we want the wall to be breakable, for instance. So has health. Oh, Visual Studio's giving me another. Oh, no, it's too short. Can't take another bite. Okay. So has health. How do we build a has health component? Well, pretty simple. Let's go ahead and create a float variable, and we're going to simply call it health. And let's say everything in the game that has health is going to start at health 100. We could make that more fancy later. Maybe make a max health variable, stuff like that. But the next thing that this has health needs to allow is not just storing the current health, but it needs to allow some way for us to change what that value is. So we'll go public void adjust health, okay? This is the API that other classes and systems can use to adjust the health of this character, of this game object. So we need to allow users of this function to specify how much they want to adjust the health. So we'll call this delta, okay? Now, delta is the value by which we're going to change our health variable. And if our health becomes smaller than or equal to 0.0, we need to destroy this game object, right? Because we've run out of health. In reality, you probably don't want to immediately destroy your game object or character when they run out of health. You probably want to play some sort of death animation or something. But we'll keep it fairly simple, okay? And that's it. Like, that's it. We're done with the component. If something has health, then they are storing a float that represents their health, and they provide a function that lets you adjust that health, okay? And potentially, if that health value gets too low, the game object goes away. All right, a very, very simple component, and it's now on our player. Okay, so now we need to create our enemy. Now our enemy needs to damage the player when the player touches it. So what we can do is we can say, hey, let's create a component called adjust health upon touch, okay? It's kind of adjective-y. Okay, so adjust health upon touch. This component name essentially tells us exactly how we need to program, doesn't it? So we got adjust health on touch. Let's get back here. Let's double click to make sure that we have it. Okay. So in terms of APIs, what we probably want to do is say, hey, the designer should be able to say, hey, how much do you want to adjust? Adjustment amount. Okay. And we'll set this to a default of like -25. And then, how do we detect when we've touched something? Well, we probably want to use an onTrigger enter. There we are. Okay. And then we have a couple requirements, right? We need to adjust HP of the thing we touched, and then we need to apply knockback. And we'll fill both of these out. The first thing we want to check is, okay, we touched something, but can we even adjust health on that object? Does it even have health, right? We might touch a wall that has no has health component, and we can't really do anything to that wall, can we? So we'll do this. if other, as in the thing we touched, that get component that has health 3 is equal to null, as in, if we have, actually, let's go ahead and store this in a variable. Has health 3, other HP, we will use get component to grab that component on the other object we touched. And if that component doesn't exist, as in if it's equal to null, we're going to go ahead and return, because we can't really do any other logic until that other component has the component that they need. The other game object has the component they need. Okay? But if they do have the component they need, what we'll do is we'll use that function, adjust health. How much do we want to adjust health? By this amount. Okay? One of the interesting things about this function, right now you're thinking about this function, this component, in terms of, hey, it lets us damage enemies, right? It lets us damage the player. It lets us damage any game object that has health. However, what happens, chat, riddle me this. What happens if I take this negative amount and I make it positive? What happens if this adjustment amount isn't negative, but it's positive? It no longer looks like an enemy, does it? Or a trap or a hazard. It looks like what? Yeah, it does healing. And enemies don't heal, but what does heal? While I finish my egg here. Bingo. Bingo. That's right. If we change this adjustment amount to 25 and not negative 25, and we put this on another object, suddenly it looks like an item. Suddenly we have an item implemented, right? So it's kind of crazy how reusable this simple component already is. Okay, so the next thing we need to do, by the way, we need to always write some code and then test it before moving on to other features. So health change to, let's do this, other HP. Actually, no. Let's put it in that function. Okay. So within adjust health, whenever our health gets adjusted, we're going to go ahead and we're going to print what that new value is. Okay. And then we're just going to make sure that our collisions and all of that are working. So we're going to go bump into that ball, and hopefully our console will tell us that our HP has been adjusted to 75. Okay? Come on, Unity. Come on. All right. We're good to go. Okay, the next feature that we need to implement, now that the previous feature is working, is we need to implement knockback. So this is the idea that when we hit another game object that has a rigid body, as in if we hit another game object that is physically enabled, we want to send it flying, right? You don't want to just take away some health. You want to like bump it, send it flying back so you can see it, right? There's an impact. It's painful. So what we're going to do is we need to check to make sure that that other object has a rigid body in the first place. If it doesn't have a rigid body, then we need to bail. But if it does have a rigid body, then we need to apply some sort of force. So we'll do add force. But the question is, what kind of force do we need to add? This function requires a vector 3 in order to actually apply it. So let's go ahead and create a new vector 3. This is going to be our force. And okay, what should the force be? Well, the force we apply should probably be the vector that points from the enemy to whoever touched us, right? So from ourselves to the thing that hit us. We can get that vector really easily by going other.transform.position minus our position. It's always destination minus origin to get the vector that goes from the origin to the destination. So there we go, transform.position, and then we have our vector. Now we probably also want to have some upward motion to this vector, so what we'll do is we're going to add in a little bit of upward motion. So vector3.up is probably fine. And then we want to normalize this vector. We want to normalize this vector and multiply it by some value that will give the power of the knockback. So we'll update our API a little bit. We'll give the game designer freedom over how strong of a knockback effect this is. So knockback magnitude, and let's set this equal to something like 250, okay? All right, so we need to multiply by that amount, and then we should be good. Okay. So there it is. That's kind of a long line, isn't it? We'll go ahead and make it a little bit shorter. Cool. So we'll apply that force vector. We've written a nice chunk of code here, so we'll now test it. Let's go and bump our ball. Bump our enemy. Hello. All right, good. Okay, so let's go see what happens. Oh, didn't work. Okay, so now we have to figure out why. Good thing is we only wrote a tiny bit of code, so we can probably figure this out pretty quickly. Okay, so let's go ahead and write a little bit of output to just figure out what happens. So let's see, knockback 1. And then let's see if we get past this check, knockback 2. And then we can see what our force is right here. Knockback force. And then we'll print out, see what kind of value we have, okay? All right. So now we'll filter our debug messages by knockback. Okay. We'll play it again, and we'll see what happens. Okay, we're rolling. And, ooh, we only got to knockback 1. So this is blocking us right here. Oh, that line of code makes no sense at all. If other RB, what does that even mean? It should be if other RB is equal to null, all right? It's easy to make small mistakes like that, particularly if you are if you're not sleeping super well. But you can easily find these issues by taking this iterative approach, right? You write a little bit of code, you test it. A little bit of code, you test it. Something's wrong, but because you only wrote a little bit of code, you have very few suspects to go back and investigate. And so you get the bug solved very quickly. Boink! Do you see that? Oh, it looks great. Like boink, ouch, ouch, ugh, right? Okay, so it's working. It's great. And now I think if I get hit one more time, I'm going to get destroyed here. And I got destroyed. So it's working just as we expect it to, right? And this is some pretty cool behavior for what is otherwise a super small and easy to understand component, right? All it does is it simply checks if the thing I touched have health, and if it does have health, adjust health. It sees, hey, is the thing I touched, does it have physics? If it has physics, calculate a force and apply it. That's it. But we get this really cool behavior out of it. The last thing I'd like to point out to you is we used this on an enemy, but we could easily use it on an item as well. And we have this red block here, right? This red block could be lava. What if the designer wanted to make this a lava pit that you had to jump over? Well, what we could do is we could just simply add that component. Let's just add the adjust health upon touch component. We'll add it, and let's make this a little bit more painful to touch. We'll give its knockback a little bit more power, and then we can test it out. Notice we haven't written any components that explicitly are hard-coded to be enemy related. We're just writing some very general and reusable components, and we just mix and match them. Whoa! Oh my gosh, that's a lot. Yeah, that was a little bit too much. Yeah, so, but here's the takeaway. You write simple components that are hardy, so they check for the existence of other components, and they know when to bail, and you mix and match them. They're generic enough that you can apply them to many different game objects throughout your project. Okay, I'd like to show you one more thing. Chat, what do you think would happen if we accidentally added two adjust health upon touch components? Right? If we added two of these components to the same game object, that would be kind of weird, right? Because you'd apply damage and you'd apply knockback twice, and we don't really want to do that. And so what happens, we don't want our game designer, to accidentally add two of these. So how can we make our component even more defensively programmed? Well, what we can do is we can use a special attribute up here. Attributes in C# are ways of essentially adding information to a certain function or a certain class that other parts of your system can use. So Unity, for instance, if you add the disallow multiple component attribute, then it won't let you add a second component. So let's go ahead and look here. We've got we got one adjust health upon touch, but if I accidentally add another one, it will tell me, hey, I can't add that. It's already added, right? Awesome. Another cool thing you can do, and this doesn't necessarily make sense with the particular instance of it, but if you ever have a component that requires another component to work, what you can do is you can say, hey, Unity, require component. What component do you want to require? Require a has health. There you go, has health 3. So in this case, if I ever add an adjust health upon touch component to a game object, this has health 3 component will automatically be added. And then what I could do is I could do something like this. Get component has health 3, and I can get a reference to it, and I can do things with it, right? So anyway, I'll show this to you really quickly just to prove that this is how it works. Okay, so let's go ahead and remove our adjust health, and then we're going to click it right there, and boom. I added a adjust health upon touch component, but we've programmed it to be dependent upon has health 3, so that dependency is automatically added, okay? So it's pretty darn cool. Let's go ahead and clean this up, though, because that really makes no sense at all. Things should be able to deal damage without themselves having damage, like a spike wall. Maybe you never want the spike wall to be able to be defeated and destroyed. So it doesn't need health, but it should still adjust health for things it touches. Okay, that's enough of that. I think you get it. Pretty simple example, but that's generally how you want to write your components. If you want to see how this plays out in the realm of a commercial and larger kind of release, a larger game will have a ton of components like that are all super reusable and super generic and super flexible. So what you can do, as it turns out, is you can combine them, many of them, to create different and unique components without writing a single line of code. So I'm going to show you an example from a tower defense game that we're currently working on and getting there on. In this tower defense game, we have 3 kind of different types I want to show you. We have a tower game object. In this case, it's the clam you see here. There's a clam, it kind of spits at enemies, and it's all good. We then have a unit game object, which is like a person or an animal that can actually walk around and fight things, as you can see here. She's going to kick the crab in a sec, I think. We also have a map unit. It's sort of like a unit, but it's dedicated to walking around on the stage select screen, okay? So what can we do? Well, if you look at the components that are on the tower, the units, and the map units, if you look at them all, there are a ton of components, and they're all relatively simple, and many of them are actually reused across multiple objects. So has data. The has data component is literally, it's kind of like the has health component, except it's a has health component that can store any statistic. So health or attack or currency or defense or speed or vision distance. It's essentially a dictionary of string to string or string to int that just allows you to assign a stat to a character and allows you to read that stat if you want to. Okay? So all three components share and reuse that logic, which is very helpful. Two of these, the in-game unit and the in-game tower, have an has-team component. This has-team component is a storage component that essentially gives a team association to a unit. Units on the same team aren't allowed to fight each other, and units on the NPC team are special, as in no unit can fight them, and they won't help out in any fights at all. So one of the cool things about having these components and having them so simple is that at any moment it's very easy to, for instance, get rid of someone's team or to change it. You just destroy that component and suddenly they have no team, right? And everyone will attack them. It's very mean. There's another component that's shared, has desired position, right? So has desired position, all three of them have it. The center one is hidden by Google at the very bottom. But has desired position means exactly what it says. If you have that component, then you have a 3D point in space that you want to get to or you want to shoot at, depending on the other components you have. For instance, if you look, the tower has a can fire component, which causes the tower to fire at its has desired position location. The unit game object has a can punch. Essentially, that should be can melee component. Where is it? Can punch right here, meaning it can actually physically hit something. You could have a component that's a unit that can fire and it also can punch if the unit happen to have like a gun or some projectile weapon, right? Okay, let's keep going. Selectable. The selectable game object means you can hover it and click on it and do affordances and stuff like that. Has vision is shared across these two. If you want to blind a game object, like give it a status effect of blindness so it can't see or it misses things when it fires, you can just get rid of the has vision component. Easy, right? So that's the idea. You want a ton of tiny, easy to understand components that you can kind of attach to a game object, mix and match to create really interesting stuff, okay? This is a particular game. Well, I'm not going to tell you what the name of it is because it's not really finished. And I think the build that's currently up on our website doesn't quite work since we're doing a ton of refactoring right now. But it is, yeah, I'm not going to tell you what it's called, but it's pretty cool. I love the artist who worked on this, Sam Olsen. Just fantastic artist. Okay, let's keep going. It uses a lot of the same technology that Goodbye Groundhog does. So if you play that game, you'll sort of be playing this beach game. Okay, P1 architectural considerations. Let's go. BTD stands for Beach Tower Defense. That is the code name. Every Arbor Interactive game has a 3-character short code. Just for some of our back-end software and stuff. Not Bloons Tower Defense. I wish. That would be pretty great. But if I made Bloons Tower Defense, I probably wouldn't be teaching. Be living it up on a beach or something. Okay. I don't actually like beaches that much. I'd be in a cabin way out in the mountains. Okay, so I want to talk to you a little bit about P1 architectural strategies. The idea that you finished P1 milestone. You've created your first enemy. You've created your first weapon. But now you need to create more of those things. So what kind of architecture can help you scale that out in a way that's going to be effective and efficient and reuse code and avoid copy-paste issues, right? So let's go ahead and think about that for a little bit. You have 3 enemies here, okay? You've got the Stalfos, you've got the Gel, and you've got the Goria. You have a few more in the actual project, but these are the ones we'll consider. Now, your objective, let's say, is to get them moving, okay? You just got to make them move. And what's interesting about these enemies is that when it comes to moving, they move in a pretty similar way, don't they? Right? These enemies all move kind of on the grid, on a tile, sort of like in Pokemon, right? There's a very pronounced movement grid. and they're a little bit unique, right? The gel kind of stops and starts, but the Stalfos and the Goria work very similarly. The Goria kind of stops and starts too sometimes when it's firing. But your objective is to get them moving. And so the question for you is, okay, should we create one component and have all three of these enemies use that component? Or should we create three unique components? The Stalfos move, Gel move, and Goria move, right? And there are pros and cons to both of those decisions, and you're going to have to make that decision pretty quickly. The advantage of going with the one component route is that if you have one movement component that all three of these enemies use and reuse, then you have dry, right? Your movement logic is only in one location. So if you fix a bug in one place, it's going to fix that bug every place, which is really, really nice, okay? It's also really easy to reference in a generic way. Here's what I mean by that. If you ever want to, for instance, turn off the motion on a game object, then all you have to do is this: get component, movement, and then .enabled equals false. You just turn off the component. It's really, really nice. A question in chat. They all share the same movement logic, but have different AI logic for determining how to move. Yeah, I mean, so one thing you could do if you wanted to make this one component is you could add some properties to this component, some public, public bool blah or public int blah. That might determine like, hey, when should I stop? How long should my stops be? Stuff like that. It should be random, should be something else. And then you might have AI that determines when this is going to be enabled or not. Disadvantages of this approach is that this can be kind of challenging to implement, right? These movement patterns are very similar, but they're a little bit unique, right? So you need some ways to adjust how the component works, and that can be very challenging. An advantage of going with three different components is that it's much easier to implement, at least to begin with. Right? You just knock out each one. You just write the custom code that you need for each one of these game objects. You're not reusing anything. If you do reuse any logic, you're copying and pasting all that logic in. However, that comes with some very nasty downsides. It fails dry, the dry principle. So copy pasting is going to happen, and if you fix a bug in one of these three, you have to remember to fix it in all of the other movement components that you have, potentially in your entire code base. And this gets worse the more enemies and the more movement related components you have. Okay? And another really nasty thing is that you cannot reference this generically. Okay? Here's what I mean. Let's say that we want to turn off movement for this enemy when we touch something. Let's say you create a custom mechanic where you've got a weapon that freezes enemies in place. Well, what you can do, if you have only one common component for movement that everyone is using, what you can do is you can reference it generically. You just do collision.getComponent, so get the component on the thing that I collided with, and turn it off. It's easy. You know that the enemy is going to have the movement component because that's the only movement component that exists. However, if you have one movement component for every unique enemy, it's going to be a pain in the butt. What you're going to notice is that you get into this pattern, okay? You have to manually grab every component type and turn it off because you can't just say, hey, grab me the movement component, okay? Because they'll ask, well, which one do you want? And it's actually worse because you can't write just 3 lines, you need 6 because your Stalfos might not have the gel movement component. Your gel might not have the Stalfos movement component. So you have to make sure whatever you're touching has the component that you want and turn it off. You have to do all of this. It's very nasty. And what's even worse is that every time you create a new enemy and a new movement component, you have to remember to add 2 new lines to this piece of code. This logic needs to grow by 2. And let me ask, are you going to remember that? Are you going to remember that every single time you need to? What if an intern were to join your team and, creates a new enemy with a new movement component, but has no idea that this bit of logic even exists. Guaranteed bug, right? Guaranteed bug. What happens if you add what happens if your teammate adds a new movement component to the game because you're sick or something, and and they're doing your movement related work, and they forget, they don't know about this, that they have to maintain this logic? Then you've got a bug. Suddenly your freeze weapon is just not going to work on that enemy until you find that issue and fix it up. And so in general, if you ever write a piece of code and you think to yourself, you know what, I need to come back and update this code every time I do something else, that is really not good, okay? That is just going to generate bugs like no other, because you probably will not remember to maintain all of the various maintenance points that you need, okay? And so if you ever find yourself writing this code and saying, hey, I know I'm going to have to come back here if I ever add a new item to the game, if I ever add a new enemy to the game, if I ever add a new level to the game, then that's bad news. That is a hint that you need to take a different approach. But what are the different approaches? Well, here is a different approach, okay? Well, actually, here's something to consider. Think about this. What if we added a bat to the game, right? These three have very similar movement, but this Keese does not move remotely like these three, okay? Do you want to create one component that can handle all four of these? No way. It would be next to impossible to do a good job writing one component that deals with all four of these different movement styles. These three are very similar, but this one is totally different, okay? If you try and do that, you're going to end up with a 4,000 line component that is super complicated and big and does more things than it needs to, and it's hard to debug. So don't do that, okay? You would want to create two components in this case. Here is two ways that you could fix your issue of maintenance, all right? So one thing you could do is you can use inheritance, okay? Instead of having a humanoid grid movement, or instead of having a Stalfos movement and a Goria movement and a gel movement, what you can do is you can have a humanoid grid movement component, and then for the Keese and the bats, you can have a flying component, okay? Flying movement component, and they will both inherit from movement or movement component. By inheriting, what you can do, if you look in the bottom left corner, Google's going to block it if I take my cursor down there, but what you can do suddenly, if you look down there, is you can just refer to the base class component, and the getComponent function will give you whichever one is on that object, okay? So by doing this, we have gone from this setup, which is super unmaintainable and doesn't scale well at all, to this nice one-liner, which does scale, okay? So that's a really, really nice approach. You also share logic. So if there are certain variables and certain functions and pieces of logic that are shared between your flying movement and humanoid grid movement, then you can put it in that base class and you get back a little bit of dry, okay? Reduces the odds of copy-paste bugs. Another thing that you can do is you can take the intent component approach. An intent component, for instance, let's say you create a has intention component. It's just a component that stores some control logic on it. It stores a variable, like a bool, wants to move. It stores a vector3, desired position. You can think of it like a brain. Okay, the brain has desires and information that your hand component uses, that your leg component uses, that your mouth component uses. Okay, and so your Stalfos will have a has intention component. It's the brain of the game object. And what it will do is in the bat movement, so this is Keese. The Keese will have a has intention brain component, and within its bat movement component, it will grab it, it will check to make sure that it exists, so it has a brain, and make sure it wants to move. And if it wants to move, it will actually execute that movement, okay? That bottom line there. In the other component, like humanoid movement, it will do the exact same approach. It will grab the brain component that has intention, it will check to make sure this game object wants to move, and if not, it doesn't move. As a result of this, you can now reference and turn off